Hello, my name is Hardik Acharya and I will be explaining a higher level overview of the mobile cloud applications. As you can see in the diagram, the higher level overview shows that there are two basic parts. One is the cyber physical system and one is the cyber virtual system. Cyber physical system uh, has a lot of parts such as mobile ad hoc networks, cellular and data networks, social networks, vehicular networks, and mission critical networks. These are all heterogeneous network systems and they don't mix with each other. Neither they interact or um, correlate to each other. While on the other side is the cyber virtual system, which is abstracted network systems in which all the resources are connected to each other and interact with each other on daily and very regular basis. Cyber virtual system consists of computing resource, storage resource, networking resource, and the main developer control happens here. In this part, the developer needs to be situation aware and he has to think about how the apps are going to interact with the humans in the cyber physical system. The developer has to be proactive and has to take care of the security and privacy and protection of the apps. And through the protection and privacy of the apps, he has to take care of the protection of the human beings or the networks that are being used by these applications. So the applications are developed and created in the cyber virtual system and then they are being used in the cyber physical system, and the whole and they both integrate and combine to become the whole cloud application network. And this is mostly what is explained in the diagram. Here are some of the advantages of what mobile cloud computing provides. First being flexibility. So yeah, whenever a developer wants to access the information, he can access it from anywhere because the data that is being stored is uh, because it's stored in the cloud and the users also can access their information from anywhere in the world. The second point is multiple platform supports, because cloud is not platform centric. It can be run on any of the platforms across the world, be it a web application, be it a mobile application, iOS, Android, and in whichever coding language it has been created in. The third is cost efficiency, because at the start in cloud mobile applications, the cost is really minimal because all the services provided are provided by the cloud providers rather than the developer himself. So the developer does not have to care about the servers or maintaining the systems and crashes. All he has to do is just take care of the code. That's it. And then the fourth is real-time data availability. So across all the devices, the data is real-time synced, and whatever data is provided by the user is synchronized between the web application and the mobile application. This gives it a very distinct advantage over the other cloud applications. And the last one, which is that data backup and restoring is really seamless and easy because the data is stored in the cloud, and even if the local directory is somehow corrupted, the data is always stored in the cloud and it's not corrupted, so it can be backed up easily and restored easily. Now let's talk about the disadvantages. Mainly there are two and they are pretty big. The biggest is data privacy. The data that is stored in the cloud is in the hands of the cloud provider and the user does not have any say in how the data is saved. So if there is a breach in the cloud provider's services, then the data which user or the developer had trusted to the cloud provider is leaked. So the data privacy is a big disadvantage that mobile cloud provides. And the second is that the cloud vendors and the cloud service providers do not play well with each other. So it is hard to migrate from one cloud provider to another. For example, if a company is using AWS or Amazon Web Services, then it is really hard for the developers or the company to shift and migrate everything that they have created and developed in Amazon Web Services to Google Cloud Services, because both of them don't play well with each other.
Hi, I am Prdayut Ghosh. I will be discussing AWS mobile services. AWS mobile services basically consist of five components: AWS Amplify, Cognito, Pinpoint, Device Farm, and AppSync. AWS Amplify is the core part of the AWS mobile services. Cognito, Pinpoint, Device Farm, and AppSync are the other services that supports AWS Amplify. Basically, Cognito is used for authentication and access control. Pinpoint is used for communication protocol. Device Farm we use for testing purposes, and AWS AppSync, which is used for data synchronization across various platforms. AWS Amplify is an open source JavaScript library provided by Amazon Web Services that enables the developers to build applications with cloud services on the web or mobile platform. It seamlessly provisions and manages mobile backend and provides a simple framework to easily integrate backend with iOS, Android, web, and React Native frontends. As you can see in the diagram, there are mainly three components of the AWS Amplify, which are like framework, cloud services, and developer tools. And these three parts are integrated in one CLI. Now we will be discussing Amplify framework. The Amplify framework provides a set of libraries and UI components and a command line infrastructure to build mobile backends and integrate them with your iOS, Android, web. The Amplify CLI allows you to configure all the services needed to power your backend through a simple command line interface. The Amplify library makes it really easy to integrate your code with your backend using declarative interfaces and simple UI components. In the slide, you can find how to install the CLI. Now the library is very easy to use. You can choose your cloud services and easily connect them to your app with just a few lines of codes. It has a very powerful toolchain. We can create sophisticated serverless backend really fast. The CLI includes supports for authentication, analytics, functions, GraphQL APIs, and much more. The toolchain uses AWS Cloud Formation and enables you to add, modify, and share configurations. The APIs are really easy to create, and the framework has the benefits of UI components too. Amazon Cognito says you can spend your time creating great apps and let Amazon Cognito handle the authentication part. Amazon Cognito uses user pools to provide a secure user directory that scales to hundreds of millions of users as a fully managed service. Users pool are really easy to set up without any worries about standing up server infrastructure. With Cognito, your users can sign in through social identity providers such as Google, Facebook, and Amazon, through enterprise identity providers such as Microsoft Active Directory via SAML. Cognito User Pools is a standard-based identity provider and supports identity and access management standards such as OAuth 2.0, SML 2.0, and OpenID Connect. Cognito also supports multi-factor authentication and encryption of data at rest and in transit. Cognito provides solution to control access to backend resources from your app. You can define roles and map users to different roles so your app can access only the resources that are authorized for each user. With a built-in UI and easy configuration for federating identity providers, you can integrate Amazon Cognito to add user sign-in, sign-up, and access control to your app in minutes. You can customize the UI to put your company branding front and center for all the user interactions. Now we'll come to AWS AppSync. AWS AppSync, as the name suggests, is the services to provide backend synchronization. For example, when someone registers and creates a new account on Netflix, the same account can be used to log in into the web application as well. This is done using AppSync. AWS AppSync uses GraphQL to make it easy for applications to get the data they need. AWS Lambda also uses the GraphQL, which is why AppSync can work with various data sources like NoSQL data sources, relational databases, HTTP APIs, and even custom data sources like AWS Lambda. It has some benefits which I'll discuss. Like, it helps to create slightly highly scalable applications without much fuss or long procedures. This is achieved using AppSync management console to automatically generate API and client-side code. The console is also integrates other Amazon services like DynamoDB, Lambda, which enables developers to create complex applications and scale them effortlessly as the business grows. It provides real-time subscription, which means that when a specific event happens, the real-time subscription can send notifications to users of a particular event that has subscribed for. For example, when a new series is launched or a new episode is released on Netflix, the application can send notification to the user. It also provides offline access, as when the device goes offline, as well automatically reconnect and sync the data when the device comes back online. With offline data sync, AppSync only modifies the data instead of the whole data set. It also provides data unification and allows the developer to perform complex queries as it uses GraphQL. It allows fine-grained access control. So Amazon Pinpoint is the communication protocol for the Amazon mobile cloud services. It makes it really easy to send targeted messages to customers through multiple engagement channels. In the diagram, you can find that there is something called audience management. So what exactly it does? Suppose I am a Netflix user and I watch a lot of TV series. So on the basis of that history, whatever I have watched, this Amazon Pinpoint can send me push messages like you may like this TV series or something like that, or maybe some new releases is there, so it can send me some push notification that for this TV series the new episode is launched. There are something you can see campaigns and journeys. What happens here? In campaigns and journeys, maybe there are some like Netflix original TV series and Netflix wants to promote it for 1 month or maybe 2 months. So that can be done using these campaigns and journeys. Transactional messages like your based on your subscription or your pricing, these transaction messages can be sent. Channels, it delivers messages through the email, SMS, voice or push notification. And you can see engagement data. It basically analyzes whatever the push notifications or the messenger sent. Maybe you get a push notification but you just reject it. Maybe you open it and you also start watching the TV series. So it always maintains an analytics of the total history whatever you are sending through Amazon Pinpoint. AWS Amplify Console is a continuous delivery and hosting service for mobile web applications. As an example, the AWS Amplify Console provides a Git-based workflow for deploying and hosting full-stack serverless web applications. A full-stack serverless app consists of backend built with cloud resources such as GraphQL or REST APIs, file and data storage, and a front-end built with single-page application frameworks such as React, Angular, Vue, or Gatsby. Now, as we can find in the diagram, the Amplify console accelerates your application release cycle by providing a simple workflow for deploying full-stack serverless applications. You just connect your application code repository to Amplify console and changes to front-end and back-end deployed in a single workflow on every code commit. AWS Device Farm is an app testing service that lets you test and interact with your Android, iOS, and web apps on many devices at once, or reproduce issues on a device in real time. You can add more than 2,500 devices to your private lab for testing in the cloud. The collection of the devices that can be used in the lab is massive and regularly updated, which provide various models and iterations of devices being launched in the market for both Android and iOS. It provides built-in automation frameworks so that the app can be tested in parallel against massive collection of devices. Also, the developer has a remote access to interact with the devices using gestures and swipes in real time using the web browser. The developer can choose the test to perform, reproduce and fix user faster, simulate and real world environment. Now discuss about the AWS Amplify pricing. AWS Amplify console is priced for two features. One is build and deploy feature, which is $0.01 per minute, and another is hosting feature, which is $0.15 per GB served and $0.023 per GB stored. And AWS also have some free use tier, which is 1000 build minutes per month for build and deploy feature, and 15 GB served per month and 5 GB data stored per month for the same hosting feature. Let's talk about some pros and cons of AWS Amplify. Pros are: the design of the CLI is intuitive. It follows with logical and simple questions for each command. Also, the hints to abstract the complexity are very clear. It also have clear and transparent reports. It means the tools does something even when there is a negative response. It also provides seamless user management flow user interface. The cons are overlapping of functionalities with various AWS products. An example, the real-time subscription services in AppSync has a very similar functionality to what the Amazon Pinpoint does for targeted notifications. And also, it is not matured enough when compared to competing the services like Google Firebase.
Hello, this is Hardik again, and now we're going to start on the discussion of Google Firebase. Google Firebase is a mobile and web app development platform that provides developers with tools and services to help them develop high quality apps, grow their user base, and make profit. One of the major features is that it helps build apps without the need of managing infrastructure, and it integrates high functioning services that are already established in Google. Firebase services can be divided into two major groups: app development and the app growth. Now let's talk about the app development part of it. So the first is Cloud Firestore. This is a service which is a NoSQL document database that lets the developer easily store, sync and query data from the mobile and web apps at a global scale. Some of its features are that the data is structured in tree format, which is easy to retrieve and easily scalable from the start. The apps are truly serverless from the day one by using cloud functions, which will be discussed down in the further slides. It allows to sync data across devices and platforms. Also, it allows the developer to make changes to the data even when the device is offline. Also, it provides precise and highly modifiable access control for the users. The next one is real-time database. This database shares similar features to the Firestore that we discussed just above, but the main difference is that it is cloud hosted and syncs the data in real time. So the main features are that it has real-time syncing, it is optimized for offline use, and similar to the Firestore, it has fine-grained access control. The third one is machine learning kit or the ML kit. This is in its beta stage right now, but what it does is that it lets the developer bring powerful machine learning features that Google has already perfected to the app. It works on both Android and iOS and can be used by beginners and even practiced machine learning developers. It provides production ready API that can be used for common use cases. The API can be used on the device or in the cloud. So it also improves on that quality. Also, it can be used to deploy custom models as it supports TensorFlow Lite models. The next one is cloud functions. This is an important one. So as Firebase is serverless. There is no need to manage the servers, and functions can be created that are triggered by Firebase product and be used. Another feature which is of the cloud functions is that it is very low maintenance. And the final one is that the cloud functions keep the logic private and secure from the client code. Thus, the security of the logic cannot be reverse engineered, and the application cannot be hacked using reverse engineering methods. Firebase authentication, as the name suggests, is the authentication protocol used by the Firebase, and it aims to make building secure authentication systems easy while improving the sign-in and onboard experience for end users. It provides an end-to-end identity solution. It provides customizable open source drop-in authentication solutions which implement best security practices. It is very easy to set up and can handle complex tasks such as account merging. Firebase hosting is a production grade web content hosting for developers. Firebase hosting is SSD backed, which means that the content is cached on SSD on CDN servers, so it is fast no matter where the content is being delivered to all across the globe. Also, another feature that is very interesting about the hosting of Firebase is that the SSL certificates are free of cost for custom domains. And the final one is that the ease of use, which is that only one command is needed to deploy the app from local directory to the web. Cloud storage is the last one in the app development section. Cloud storage is a standalone solution for uploading user-generated content like images and videos from iOS or Android devices. It is a very simple folder/file system, and this is how it structures its data. It also provides storage, automatic scalability, security, and network resiliency. Cloud storage stores applications in Google Cloud Storage bucket, making them accessible through both Firebase and Google Cloud. Now let's come to the app growth part of it. The first one is Crashlytics. As the name suggests, Crashlytics provides in-depth analysis of the crashes. It helps in prioritizing the crashes so that the developer can understand which issue to tackle first. It also keeps logs of all the crashes and provides real-time alerts for new issues, old issues, and the issues which need immediate attention. The next one is performance monitoring. It shows how the app performs from users' point of view with automatic and customized performance tracing. It points the origin of the issues. It provides insight on how the apps perform, and it also provides the context in which the app's performance issues takes place and help understand how easily and how to address them. Also, it has automated traces which can be directly implemented without any customization. The last one is that it can also monitor network behaviors to provide important analytics. The next one is test labs. This provides the developer with physical and virtual devices that allows him to run tests that simulate actual environment usage. It integrates existing workflows and also has automated smart tests if the developer does not want to code. It provides comprehensive test reports including logs, screenshots, and videos. Next, we come to cloud messaging. Cloud messaging is the in-app messaging service that helps the developer engage with the users who are actively using the app. It is able to send trigger messages based on the behavior and the past history of the user. For example, if a person or a user is watching a TV series or is repeatedly clicking on an ad, then the developer can send him messages or in-app notifications regarding that similar level or the similar product. The third is that it provides insight into the performance of the tailored messaging campaigns. So for example, let's suppose that there is an app which has two TV series developed by the app or produced by the app itself. Then tailored messaging campaigns can push those more uh, towards the users and increase the views on that series. Next is prediction. Prediction applies machine learning algorithms to app analytics data to create user segments based on predicted behavior. It helps the developer personalize the app experience to improve user retention using Google machine learning algorithms. The next one is Analytics, which is Google Analytics. It provides free unlimited reporting on up to 500 distinct events. It provides user insights for acquisition to app usage. Google Analytics for Firebase also provides real-time analytics, segmentation, and optimization in one dashboard, and it allows seamless integration with AdMob for revenue streams. The next is Remote Config. Remote Config is the cloud service that lets the developer change the behavior and appearance of the app without requiring users to download an app update. It can make the changes without republishing, just as I said. Also, it helps the developer customize and tailor the app according to specific user groups. And the next one is app indexing, which is that the application is shown on top of the results in the Google search. The next one is Firebase A/B testing, which is alpha beta testing. It gives the developer the power to test changes to app's UI to see if they are functional. In A/B testing, the developer can customize the experiments to test variety of updates. It also provides analysis on backend and helps to determine the best performance updates and reduces the chances of negative repercussions in the later stages of the app life cycle. This feature also reduces engineering time, as it takes a lot of engineering time to create infrastructure for deploying and testing the apps. This feature reduces all of that engineering time. The last one is app distribution. App distribution helps in managing beta testing programs. It provides valuable pre-release insights, and also it is very easy to use and flexible in nature. Now we come to the Google Firebase pros and cons. The pros are that is completely serverless from the start. It is highly secure, and the changes can be made and synchronization can be done real time. While the cons are that there is no map reduce, there is no aggregation, and the databases are designed in such a way that the querying and indexing is limited and is compared to other services and competing services. Google Firebase pricing. This slide does not show the complete pricing chart because it was too big to be put up in one slide. The main highlights are here on the slides. First is that Google provides a couple of products for free in whichever plan you go, which is alpha beta testing, analytics, app indexing, cloud messaging, crashlytics, performance monitoring, and predictions. And then there are the paid services. Out of those three paid services, uh, pay as you go plan is the best suited and it's the most scalable. In that, authentication is $0.1 per verification. Cloud Firestore uses $0.18 per GB. Cloud functions require zero point 0.4 per million functions. Hosting and storage are the same and they are 0.026 per gigabyte. And Test Lab requires $1 per device per hour.
Hi, my name is Aneri Oza. Today, I'm going to talk about Microsoft Azure services for mobile applications. Azure provides integrated services for development of mobile application, which includes Xamarin, App Service, Visual Studio App Center, notification hubs, Azure Maps, and API management. Here, the Azure services like Xamarin is a Microsoft's technology for creating 100% native applications. Xamarin creates Android, iOS, and Windows apps with native performance and user interface using existing skills, teams, and code. Cloud computing platforms like Azure tend to be less expensive and more secure, reliable, and flexible than on-premises servers. App Service adds intelligent backend services, authentication, offline data sync, and secure integration with cloud and on-premises systems. Visual Studio App Center. It quickly creates high-quality apps for Android, iOS, Xamarin, React Native, Unity, and Cordova. It integrates globally scalable backend services with just a few lines of code. It automates your build, test, and distribution pipeline and continuously monitors the real-time performance. Notification hubs sends personalized push notifications to any mobile platform and from any backend. Azure Maps. It creates location-aware web and mobile applications using simple and secure geospatial services, APIs, and SDKs in Azure. Deliver seamless experiences based on geospatial data with built-in location intelligence from world-class mobility technology partners. API management. API management publishes API in minutes, manages access, gains insights, and fine-tunes performance and provides demand scaling. As explained in previous slide, Xamarin is 100% native and it includes iOS apps, Android apps, and UWP apps. We can use .NET and C# to create these apps, as well as we can create a shared logic between these apps. As a result of which, apps built using Xamarin leverages the platform-specific hardware acceleration and are compiled for native performance. It performs full ahead of time compilation on apps to reduce startup time, increases memory sharing, and improves performance. It is an open source and free app as well as can be developed on Windows and macOS and run on iOS, Android, macOS, tvOS, watchOS, and more. Native and cross-platform integrations such as access to the full spectrum of functionality exposed by underlying platforms such as ARKit, Core ML, Fingerprint, Bluetooth, NFC, etc. It integrates with thousands of third-party libraries. Xamarin extends the .NET platform with tools and libraries specifically for building apps on iOS, Android, macOS, and more. Xamarin adds to the .NET platform the base framework for accessing native features, extensible markup language known as XAML for building dynamic mobile applications using C#, libraries for common patterns such as Model View View Model (MVVM), platform-specific libraries that includes access to APIs from Google, Apple, Facebook, and more to add rich capabilities. Visual Studio App Center is a highly scalable backend service with enterprise-grade security for authentication, data management, and push notifications. It manages, persists, and syncs app data globally in the cloud for both online and offline scenarios with App Center data. It manages push notifications to multiple platforms using App Center Push. It maximizes development productivity. It automates build, test, and release pipeline on every commit. With every successful build, automatically runs UI tests on thousands of real-world devices and OS configurations with API with App Center test. Releases respective app builds to beta testers or public app stores with App Center distribute. Deployment of hotfixes and updates directly to the users devices with code push. Continuously monitors app performance and usage. Prioritizes and fixes important issues with intelligent cache grouping, complete stack traces, and detailed cache reports. Drives meaningful engagement. It manages push notifications to multiple platforms with App Center push. Sends personalized messages targeting specific user groups via audience segmenting or target users by identity using App Center authorization. Azure Notification Hubs is massively scalable mobile push notification engine for quickly sending millions of notifications to iOS, Android, Windows, or Kindle devices working with APNs, that is Apple Push Notification Service, GCM, that is Google Cloud Messaging, WNS, that is Windows Push Notification Service, and PNS, that is Microsoft Push Notification Services. And there can be more too. Tailor your notifications to specific customers or entire audiences with just a few lines of code and do it across any platform. Notification Hubs is flexible enough to plug into any backend, Microsoft, .NET, PHP, Java, Node.js, whether it's located on premises or in the cloud. This makes it easier to instantly update your mobile apps and engage your customers. Broadcast push notifications to everyone at once or target specific customer devices using the notification hub's tagging feature. Tags let you segment customers based on activity, interests, location, or preference, so you deliver the right content of the right person at the right time. Notification hubs give you a handy way to send localized push notifications, so you are speaking to customers in their languages. Quickly scales to millions of mobile devices and billions of notifications without re-architecting. Azure Map Services creates location-aware web and mobile applications using simple and secure geospatial services, APIs, and SDKs in Azure. Delivers seamless experiences based on geospatial data with built-in location intelligence from world-class mobility technology partners. There are various operations which can be done using Azure Maps, that are Azure Map Services, such as search. For example, you are traveling and you need to figure out a nearest gas station. Well, Azure Map Services come handy for searching as well. It searches the nearest gas station and provides you with the details. The location capabilities are natively built in by Azure Maps. Built-in capabilities for search, rendering canvas in various shades and colors, and even traffic services. In this, the traffic would be to develop mobility solutions that improve travel time and avoid gridlock. That means it provides you the shortest route or the route without the jam. Another Azure Map service is routing. It presents the shortest or fastest route available to destinations, provides specialized routes and facts for walkers, bicyclists, and commercial vehicles. It optimizes the route calculations with isochrones, which provides the route range, and matrix routing and batch routing, which provides the route optimization. Geolocation preview, that is, look up the country of an IP address. Customize the content and services based on the user location and gain insights on the customer's geographic distribution. It provides other services such as spatial operations, data service preview, mobility preview, and weather services, which are pretty simple to understand. API management. API management is one of the Azure services which is fully managed. API providers use this service to expose backend APIs to the app developers. It consists of three things: management plane, developer portal, and gateway. The management plane can be viewed as APIs in an API. The API providers interact with the management plane to manage the API. The developers interact with the developer portal where they discover the APIs and how to use them, play with them, and request access to the APIs. The gateway sits in between the apps and the backend APIs, and it serves as front-end facade for these APIs. All the traffic to the API flows through the API management gateway. This is the view to improve discoverability. Create a customizable developer portal for all of the APIs the user needs. Easily share APIs with internal teams, external partners, and the customers. API management transforms existing services. It automatically turns legacy web services into modern REST-based APIs by creating facades for your back-end services. Here, the client connects to the application servers. They mainly run and manage in Kubernetes. They communicate in current networks, banking infrastructure, and communicate with each other to some extent through either events or direct calls. Azure Mobile Cloud Pros and Cons. Pros. Unlike other vendors, Microsoft Azure Cloud offers high availability and redundancy in data centers on a global scale. Microsoft Azure has a strong focus on security, following the standard security model of detect, assess, diagnose, stabilize, and close. Paired with the strong cybersecurity controls, this model has allowed Azure to achieve multiple compliance certifications, all of which establish Azure as in the top of infrastructure as a service security. Not only it is platform protected, the end user is also covered with Azure. Scalability. Scalability is the backbone of any cloud provider. Microsoft Azure makes it easy to scale compute power up or down with nothing more than a click of a button. With this scalability structure, businesses have the flexibility to pay for only what they use. It is imperative to keep IT budgets in mind when choosing a cloud provider, which is why when we researched Azure, we saw that the platform is attracted by many organizations. Azure's pay-as-you-use pricing allows SMBs to better manage their IT budgets, purchasing only as much as they need. Cons: Azure needs to be expertly managed and maintained, which includes patching and server monitoring. Azure requires expertise to ensure all moving parts work together efficiently. Azure Mobile Services provides three tiers: free, basic, and standard. In the free tier, it provides up to 10 services per month. In this, every service is limited. For example, it has 500K API calls, 500 active devices. It has limited real-time messaging and WebSockets, and many more which you can see on the slide. Next tier is basic. It costs to 14.99 per month per unit. In this, it provides 1.5 million per unit API calls. The active devices can be unlimited, but it scales up to 6 units. It has various unlimited and included services which you can further notice on the pricing list. The next tier is the standard. Here, the price would be 139.99 per month per unit. This includes 15 million per unit API calls. In this standard tier, the active devices, the scale, the push notifications, the real-time messaging and WebSockets, and every other service would be unlimited and included.